Hi everyone, this video lesson is your first lesson in the chemistry unit. Today we will be classifying matter and properties. But first let's start with a definition of chemistry. So chemistry is the study of matter as well as the changes it undergoes. So we think of chemistry, we think of chemical reactions. We're curious to see how substances react with each other and how they change when they do so. What is matter? You may have heard of it before, but matter is anything that has mass and volume, which means it takes up space. So you could say matter is anything that has mass and takes up space. So for example, a solid would be ice or a rock or your desk that you're sitting at right now. Liquids would be anything like water or milk or juice. And gases would be something like water vapor, oxygen, or carbon dioxide. Next, let's look at the particle theory of matter. So first, we have matter is made up of tiny particles. So everything you see, everything that is matter, that has mass and volume, or it takes up space, it's all made up of tiny particles if you were to zoom in very closely. And two, all particles of one substance are the same. So you'll see substance A, this black block, all of these particles would be the same. And same goes for the white block. All of the particles in this substance would be the same as well. Number three, particles are always moving. So in solids, they're vibrating in a fixed position, and that's why solids don't just move around and flow. But gases are very fast, so that is why they spread rapidly and it's hard to contain. Four, particles are separated by empty space. So here we have some particles and there is empty space between it. And five, particles are attracted to each other. If they are further apart, that means they have a weak force, and if they're closer together, they have a strong attractive force. Let's talk about the different states of matter. So here we're going to describe the difference in the three states, which is solid, liquid, and gas. So in our diagram, we would draw something that is very close together, because this is our fixed position. Something like that. In terms of volume, it is fixed. You can't change the volume of a solid unless you add more to it or take some away. Same with the shape. It is also fixed because you can't just change the shape of your desk again unless you add to it or take it away. It doesn't just flow and move freely. Attraction, it is the strongest. Remember, these particles are very close together, and that is what makes them a solid. And finally, movement, we mentioned it on the last slide. You would say it's a vibration. Next, for liquid, you would draw these particles a bit further apart. And for volume, it is also fixed. You cannot change the volume of a liquid unless you add more or take some away. The shape, however, can change because the shape of a liquid just takes the form of the container it is in. For attraction, it's somewhere in the middle. It kind of flows, but you can kind of keep it together. And for movement, we would say this is fast. Lastly, for gas, these particles we would draw very far away. For volume, the volume can actually change. And that is why we can have gases under pressure, because we can change the size of the container it's in and therefore change the volume of the gas. In terms of shape, this would also change, and that's why gases spread and move freely. For For attraction, of course, we have the weakest. It is hard to keep a gas together when it's not in a small fixed container. And for movement, we have the fastest. Next, let's classify matter. So everything on Earth is made up of matter, as we just talked about, but the building block for all of this matter is known as the atom. It is the smallest unit, and you cannot go any smaller than an atom. And so when we talk about matter, it can be divided into two main categories, which can then be divided further. So first, looking at the left side, we can have a pure substance, or if you look to the right, we can have a mixture. If we're looking at a pure substance, this can either be an element. Think of oxygen. Oxygen is an element. Or we can have a compound, which is more than one element. An example of this would be water, or H2O, because it's hydrogen as well as oxygen. But water is still a pure substance, so it falls on this left side of this pyramid. On the other side, we have a mixture. And under mixture, it can be homogeneous, or a solution, or heterogeneous, or a mechanical mixture. So a solution is something that can't easily be separated. It is kind of all of the same thing. But a mechanical mixture would be something that can be separated and you can clearly see the parts in it. So a good example I like to use for this is Rocky Road ice cream, which is the ice cream that has, I think, marshmallows and chocolate and other things in it. So you can see all the separate parts, so it's a mechanical mixture. We'll go over this a little bit more on the next slide. Let's look at these diagrams to further our understanding. So first, under pure substance, we have an element. So it's all of the same kinds of atoms. They're all the same. That is a element. But under compound, we have multiple atoms that join together. In this case, they're forming a molecule. So this one could be water, for example. This could be a water molecule, and it's two or more atoms coming together to form a compound. Now let's look at the mixture side. And first we have our homogeneous mixtures, or our solutions. And this is a mixture of substances that form into a uniform mixture. So a good example I like to use for this is salt water. You put salt in water, and if you wait a little bit, it'll dissolve, and then you have salt evenly distributed throughout the water, and that is an example of a mixture, a homogeneous mixture, or a solution. Next, we have heterogeneous mixture. So like I said before, a good example is Rocky Road ice cream. You can see the different components that make up this mixture, and on top of that, it's easy to separate, or seemingly, because you can see all of the different pieces. Next, let's classify some matter. So let's look at this first description. We have contains only one kind of particle, has the same composition throughout, components cannot physically separate, and changes in state occur at a constant temperature. This would be a pure substance. And there's examples up in the top right corner. All of these images are examples of pure substances. For our next description, we have pure substances containing atoms which are of the same type. There's 114 plus elements found on the periodic table, and these building blocks cannot be broken down into simpler substances by ordinary chemical methods. And it kind of gave it away in the description, but these would be our elements. Finally, we have our pure substances containing atoms of two or more elements in a chemical combination held together by attraction or bonds, and these can be chemically broken down into elements. Take a second, what do we think? This would be our compound. And again, an example is water. It's hydrogen and oxygen together, individual elements. Next, let's look at something that has a combination of two or more pure substances, each keeping their own physical and chemical properties. The components can be separated by physical means, for example, strainers or magnets, and the changes of state occur over a range of temperatures. This would be your mixture. Next, we have a substance with only one phase, and the particles are too small to be seen with the naked eye, so you can only see one phase, and this would be our homogeneous mixture or our solution. So remember how I used the example of salt water before? It seems as if you can't separate those two substances again, the salt from the water. It seems like they're mixed permanently. However, if you wanted to, you could boil all of the water away and it would go into the atmosphere as water vapor, and it would eventually leave behind the salt. The salt wouldn't evaporate like the rest of the water. It would be left behind. So technically you can separate this mixture. And finally, we have more than one phase. It's not uniform throughout, and the particles are large enough to be seen. So this would be your mechanical mixture or your heterogeneous mixture. Looking at these images, let's first point out the solutions. So remember, it's uniform throughout. The particles are too small, and you can't even see that it's a mixture. What would some of these examples be? Well, first, we have the Gatorade. It looks like it could be all one type of specific substance, but it's actually a bunch of different ingredients. Same with the perfume. But let's, for example, look at a mechanical mixture. We can see all the different substances that are going into this mixture. A good example of that would be this pizza. Let's practice with some examples. For this activity, we're going to say E means element, C is a compound, S is a solution, and M&M is mechanical mixture. So remember, these two are mixtures, and these two are the pure substances. Always think back to that table. First, we have carbon dioxide. Let's go down the list. Is it an element? No, it's not, because carbon itself is one element, and then oxide is oxygen, and that's another one. So therefore, it would be a compound. Next, we have distilled water. And we've used water as an example throughout this lesson. Let's write it out. Water is H2O. Is it an element? No, we can see there's two different elements in here, hydrogen and oxygen. So it would also be a compound. What about chocolate milk? Think of what makes up chocolate milk. Well, it's definitely not an element, and it's not just a compound. It has to be a solution. Remember, it's uniform throughout. We can't see the different parts, so it's a solution. Blood. Take a second to think about it. Think of what makes up blood. This would also be a solution. It looks like it's a uniform substance. It's made up of all the same things, but there's actually red blood cells and white blood cells and platelets and all these components to make up blood, so it is a solution. What about colored marshmallows? This one would definitely be a mechanical mixture. You can see the different parts and you can separate them if you wanted to. You could pull them apart. What about Kool-Aid? What goes into Kool-Aid? It would be kind of similar to our chocolate milk or the blood, so this is also a solution. There's a lot of different ingredients that actually go into making Kool-Aid. but it looks uniform, so it's our solution. Vegetable soup. Let's think about vegetable soup. What do we see when we're looking at it? Well, we could see maybe some noodles or some carrots and some peas and some celery. That is definitely a mechanical mixture. And we could separate the pieces. And we could separate the ingredients in it. We could strain it and pull them all apart. So that is our mechanical mixture. And what about pure gold? Pure gold. What do we think? Pure gold is an element, and it's written like this on the periodic table. And the easiest way to find out if something is an element is going to the periodic table and seeing if it's on there, because it's the periodic table of the elements. Finally, let's look at these images. What do we think these are showing us? Think they're all kind of the same, but there's two parts to each one. So therefore, we would have a compound. If it was just all one, like over here, this is when you would have an element. One kind of atom throughout, whereas the compound has at least two. What about this one right here, below the element? What do we think? It's kind of similar to this one. It's not two. Well, actually, it is two. It's one atom of one kind and four of another kind all attached, but it's still a compound. And finally, what about this last box? And finally, what about this last box? We can see one type of thing there. This looks pretty different. So here you would have a mixture. And it could be mechanical, but it's probably a solution, because if the particles are this small, chances are you won't be able to see the difference. So we'll put mixture, probably a solution. And that concludes this video lesson.